Hello students, in the last class we had seen various distributed generators and a brief discussion of how they work. So let us continue module 1. Today we will see the integration of distributed generation to grid. So let us first see a vision for future energy distribution. This picture shows many types of distributed generators integrated and connected together and working synchronously, optimizing the energy utilization, meeting the needs, and also without damaging the environment. So now coming to integration of distributed generation to grid. So what the question is, why we should integrate the distributed generation to the electric grid? What are the technical, economic and environmental benefits of DG integration? The first one is the generation of electricity will become less centralized and more customer interactive. Remember, the distributed generators are now located at the customer premises. It means it is located very near to the load. Now we have to integrate it with the grid, means you are going to connect your generator with the grid. Why should you do it? There are many reasons. The first reason is many distributed generators, the output is not continuous. For example, if you have a solar power generating unit at your home, it will not work at night. So either you should have a battery storage unit at your home, or you should connect your solar system with the electric grid, so that during daytime you will be selling excess power and during night time you will be getting energy from the grid. So the power generation is now going to be less centralized compared to the earlier time and more customer interactive. So the customer has a greater role in generation and in using his excess generated electricity. Connection of widely distributed renewable energy sources across the network. That is very important. All the distributed renewable energy resources across the network, they are now connected together. So this connected together through the grid. So this will enable sharing of resources optimally. If you have access, you can sell it. If somebody else has access, you can use it. So a common channel for transferring energy is essential, and the grid helps in doing it. Facilitate market interactions, providing customers access to products and services with choice based on price and environmental concerns. Unlike earlier time, energy now can be traded. It's a commodity which can be traded over the energy exchanges. So if you have huge generation, you can sell it in the energy market. Also, you need not always buy energy from one particular grid operator. That is, for example, KCB. You need not buy electricity from KCB. You will be provided with a lot of choices. There may be other private companies supplying energy, other grids. So you will be able to buy, especially when you are a bulk consumer. And this is called open access. You will be able to trade energy as you like. And most importantly, price and environmental concerns. So depending on the price, you have different choices and environmental concern. For example, if you wish to use those products which are less environmentally good service providers, you can go for it. For example, I have a private supplier, he provides completely clean energy, and another one he provides from fossil fuels. I have the choice to select one from the two. Renewable energy sources is an alternative to fossil fuels. So we will be able to phase out fossil fuels and in turn reduce the carbon emissions and global warming effects. They produce distributed energy resources, produce clean electrical energy. So once again, this is of prime importance because using a lot of fossil fuels will slowly degrade our environment, which will lead to unprecedented incidents or calamities. Reduces thermal pollution by utilizing of waste heat from industries by CHP plants. This is another point. It will reduce thermal pollution. So the waste heat from the industries can be made use by using CHP plants. Reduced transmission and distribution losses. Since the generation and the load, they are very near to each other, the transmission and distribution losses can be eliminated or it can be at least reduced. DERs can be connected to form a microgrid. Yes, this is one important point. Consumers have a choice to unite and make a microgrid. What is a microgrid? A microgrid is a totally complete and independent identity, a group of consumers who have enough generating capacity to meet their loads, and also they have storage capabilities. So they can independently work and meet their load demands. They don't have to depend on the state electricity board or grid. They can also be connected. So this is called grid connected microgrids, or they can be independent, isolated microgrids. Grid connected and standalone operation of DERs improve reliability and power quality. So when your DER is grid connected, the reliability increases, because when you are connected with the grid will take care of the power quality issues. Reliability also increases because even if the grid fails, you have sufficient resources to meet your load. The power quality issues will be taken care by the grid connected grid. And during standalone means when there is a problem in the grid, your supply is disconnected. Still, your loads or major parts of your load can be met by using your resources. DG system offers fuel diversity meeting power shortage. So fuel diversity means you have the option to use solar, wind or any other type of fuel. So this diversity and meeting the power shortage is also a major advantage with integration. Energy efficiency. The efficiency will be increased by integrating DG with the grid. Optimizing electricity infrastructure replacement investment. In the traditional system, a lot of money or a lot of investment is done by the grid to have the central infrastructure, and this infrastructure investment can be greatly reduced if individual consumers start producing their own energy. With this session we will wind up. We will see again in the next session. Thank you very much.